Where deltas are absent, some long stretches of shoreline are fringed by barrier islands, which are made up largely of clean sand piled up by the waves. Some barrier islands extend laterally from deltas, but most derive their sand not from neighboring rivers, but from the marine domain. These islands are built up as waves and longshore currents, which are shallow currents that flow along the coast, winnow sediments and sweep sand parallel to the shoreline. On the beaches of barrier islands where waves break, deposits have a nearly horizontal bedding, but often have a gentle dip towards the sea. If the beach surface is irregular and changes from time to time, then cross bedding can develop. Lagoons lie behind long barrier islands, like those that border the Texas coast. We usually see mud and muddy sands make up the floors of lagoons, since the protection from strong waves allows fine-grained sediment to be trapped. This combination of barrier island and lagoon behind it forms what is known as a barrier island lagoon complex. Real original, people. These barrier islands form chains with tidal channels that separate adjacent islands, and tidal currents pass through these channels to deposit cross-bedded tidal deltas within the lagoon. Another important depositional environment along the shores of a lagoon are tidal flats, which are made of sand or muddy sand, and the surfaces are alternatively exposed and flooded as the tide ebbs and flows. Higher up in the intertidal zone lie marshes where plant debris can accumulate rapidly. When these complexes receive sediment at a high rate, they can prograde or migrate seaward, kind of like deltas. However, this migration takes place along a broad belt of the shoreline. As they migrate, the deposit of each environment progrades over the previous sediments, and they create a vertical sequence of barrier island, tidal delta, lagoon, tidal flat, and marsh in accordance with Walther's law. Follow for more geology.